Hey guys, I'm going to show you how to do a process for solving a quadratic equation that's called completing the square. The first thing that I want to do is talk through these steps for you here. If you get a little bit behind while you're taking notes, just stop the video and copy these down and then start it back up, okay? So the first thing that we're going to want to do is make sure our equation is written in standard form. The equation that I've got over here that we're going to use for an example here in just a second is written in standard form. Standard form is the ax squared plus bx plus c equals 0 format that we use for situations where we're solving by factoring, or solving with the quadratic formula, or solving with completing the square. So we're going to start with our equation in this form. Then our second step is going to be to divide each term by the leading coefficient. Now your leading coefficient is that a term, or the a value. So what we'll do is we'll divide each one of these by that leading coefficient. Why don't I go ahead and do that while we're talking through this. So the leading coefficient here is a 2. So you just divide every single term by 2. And of course over here on this end, 0 divided by 2 is just going to be 0. So it's all going to stay in standard form. We're going to get an x squared minus 3x plus 5 equals 0. Okay. And then our next step is to move the constant term to the other side. Now some applications of completing the square, we don't actually do that. We leave the term where it is, and I'll show you an example of that in just a second. But for the purposes of solving a quadratic with completing the square, it's a good idea to go ahead and move that over. So we'll do that. We need to subtract 5. So x squared minus 3x is going to be equal to negative 5. Excuse me. And then, after we've done that, we are going to take half of the coefficient on the x term, and we're going to square that value, okay? So if we look at the x term is the negative 3x. So coming off to the side just a little bit, we'll do half the coefficient on x squared. And when we square this, you'll notice that it really doesn't matter that it's a negative 3. We're still going to get the same thing. So half of that squared is going to wind up giving us a 9/4. Okay? Then the next thing to do is to add that number to both sides of the equation. So that's where we're going next. I'm going to scoot up just a little bit so we've got a little bit more room. So if I add 9/4 to both sides, I get x squared minus 3x plus 9/4 is equal to negative 5 plus 9/4. Okay. Now, we need to simplify what we've got. The next step is to factor the perfect square trinomial that we just created, because if you take half the coefficient on x and square it and then add that number back to both sides, right here where you have the quadratic, you have actually created a perfect square trinomial, which is really, really easy to factor, and I'll show you how in just a second. We also need to put these two values together. So you're going to need to rewrite negative 5 as something over 4 so that they have the same denominator there. What we'll do is we'll go ahead and factor while we're doing that to save us a little bit of time. When you factor a perfect square trinomial, it's very easy. You can use a little formula for that. You take the square root of the first term, the sign on the second term, and then the square root of the last term, which would be 3/2. Set that equal to negative 5. If I do negative 5 times 4/4, so I can get that common denominator, I get negative 20/4 plus 9/4. And then what we do is we continue to simplify. We're going to add those two values together next. Scoot up just a bit more. And what we're setting up for here, as soon as I combine these two numbers, we're going to have perfect form to use the square root property to finish the problem. So it's going to be a negative 20 plus 9. That's going to give you negative, excuse me, negative 11/4. Okay. And now when we take the square root of both sides to use the square root procedure, our last step right here, we'll get x minus 3/2 is equal to, plus or minus, the square root of 11 over 4, negative 11 over 4, and we can do a little bit of work on that. We can also move the 3/2 over by adding it to both sides, and then underneath the root you can take the I out because we have a negative under our square root. 11 isn't a perfect square and doesn't have a perfect square factor, so it has to stay under the root, but 4's square root is 2. So we can go ahead and do that calculation. If you don't like the I in front, you can carry it to the rear and put it behind the fraction instead, but that's your answer. Okay, we have completed the square and have managed to solve our quadratic that way. There's 2 answers here really because of the plus or minus. Okay, let's take a look at another application for this process. Actually, this is just another example of the same process here. So again, we would divide through by our leading coefficient, but our leading coefficient is 1. That's not going to change anything if I do that. So we add 3 to both sides. I'm sorry, subtract 3 from both sides. Okay, and then we need to take half the coefficient on x and square it. That's going to be 5 squared, which is 25. So 25 is the value that we'll be adding back to both sides. X squared plus 10x plus 25 is equal to, if I add 25 to negative 3, I get 22. And then again, this is a perfect square trinomial, so it will factor into x plus 5, square root of the first term, sine on the second term, square root of the last term. Okay. Then from here we can apply the square root property. Put a plus or minus on the constant side. And we take that square root. So x is equal to negative 5 plus or minus the square root of 22. And that's our solution there. Now we're going to look at some applications for completing the square. One thing that we can do is convert the standard form of a quadratic function, y is equal to ax squared plus bx plus c, into y equals x minus h squared plus k, and this makes the vertex of the parabola easier to find if you're graphing that quadratic function. So let's take a look at how we do that. The process is essentially the same, except this time instead of moving the constant over, we leave the constant where it is. So you would start out by dividing through by the leading coefficient, if we had one. We do not have one here. So we start, since we are not going to be moving this to the other side, we start by finding half of that coefficient on x. So I'll come off to the side and do that, like I've done before. Negative 6 divided by 2 squared. And the negative 6 divided by 2 is going to give you a 3. 3 squared is 9. So that's the number that we will be adding. But since we're not adding it to both sides because our constant is going to stay on the side that it's on, we can't compensate for putting it in that same way by putting it into both sides. So we have to do a little trick that you can use if you need to add something inside an equation, and then you've got to compensate for it happening on the same side. You can do that by subtracting that number. And we're going to do the subtraction over on the other side of our constant term there, okay? So by adding 9 and then subtracting it back out, we are effectively not changing the value of anything. We're just doing a little cosmetic surgery on our equation, okay? So it looks like we want to. Now, what's going to happen is this is your perfect square trinomial. And then this is just going to be a little constant term, okay? And if you look back at the little equation I showed you a minute ago, the formula, this is what we get when we factor this perfect square trinomial, and then this is the constant that we're going to get from here, okay? So one more step and we're effectively through with the problem. If we factor that trinomial, just as I showed you before, the square root of the first term, sine on the second term, square root of the last term, we get x minus 3, and now that whole thing's going to be squared. And then we've got a plus 1 minus 9 to finish this out, so that's going to give you a minus 8 once we put those two constants together, okay? And so that is what we're looking for right there. That gives us this form from this form, all right? And then we have another application that we can use very similar to this one. And that's where we write the general form of an equation of a circle in standard form. This is very similar to what we just did. The difference is we can pull the constant to the other side of the equation this time. Constant term is an e. So we'll be pulling that over, and we actually will make two trinomials, one with the x squared in the x term, one with the y squared in the y term, okay? So let's check that out. Come down here and do this little example right quick. Now what you'll want to do first, of course, is move that negative 3 over. Okay, so we're going to have, and I apologize that I was still in red there, we're going to have an x squared, and I'm going to collect the like variable terms together, so it's going to be x squared minus 6x, and I'm going to leave just a little bit of space, you'll see why in just a second, plus y squared plus 4y, and we're pulling 3 to the other side. Now we have to find two numbers to plug back in, so we'll take half the coefficient on x and square it. Again, that's going to wind up giving us a 9. And then we will also take half the coefficient on y and square it. And that allows us to add back a 4. Okay, so the 9 will need to be added back here. 4 will need to be added back here. And we'll have to put them both over here with the 3. Okay, so now I have two sets that give me perfect square trinomials. I'll factor both of those, and that will give us this standard form right here, okay? Perfect square factor, or not perfect square factor, but perfect square trinomial factored here, and perfect square trinomial factored here. And on the other side, this will just be a constant. So, square root of first term, not first, but sign on the second term, square root of third term, squared, plus square root of first term, sign on the second term, square root of last term, squared, and then our constant 3 plus 9 is 12 plus 4 gives you 16. And there is the standard form of that circle equation, okay? So it is kind of handy to be able to use completing the square when you need it for graphing purposes. Again, the graphing is kind of why you want the circle in the standard form, because it's easier to find your center and your radius if it's in standard form than it would be from the other way.